Hi, this is Abdullah Kader presenting for the second research project, and today I will be talking about the hydrogen fuel cell energy storage systems in smart grids. So before I start, this is the outline for today's presentation. First, I will be introducing the topic, then I will go through the fuel cells energy storage definition, type, and system. After that, I will go through the techno-economic analysis of the technology and the environmental and legal sustainability of the technology. And finally, I will briefly discuss the conclusion. So, as we all know that energy generation resources are changing with time, the dependence on fossil fuels is not going to last for the next few decades. So people have to move forward with the renewable energy resources such as solar PVs and wind turbines. However, the reliance on distributed energy resources to replace the fossil fuels will require us to have energy storage systems to overcome the intermittency issues of the renewable energy resources, such as what were found in solar and wind energy, which allows these technologies to be deployed in the utility grid. There are numerous types of energy storage systems. As we know from the first research, the potential energy storage systems to be integrated in smart grids can be classified into four categories: electric and electrochemical systems, chemical energy storage systems, mechanical storage systems, and thermal storage systems. Since there was not enough information available about the hydrogen fuel cell energy storage systems and its integration with the smart grid, I decided to investigate more in depth about this technology and this research. So a quick sustainability study or evaluation of the hydrogen fuel cell energy storage system was performed in this research, which includes technical and techno-economic, environmental, and legal sustainability study. So starting with the technology definition, a fuel cell is defined as a device that converts the chemical energy into electrical energy. The principle of fuel cells technology is very simple. The water molecules is separated into hydrogen and oxygen ions using a electrolyzer to be stored in hydrogen tanks. Then after that, when electricity is needed, fuel cells use these stored gases through chemical reactions to generate energy or electricity. A fuel cell can be compared to batteries, in which it can be recharged when the power is consumed from it. However, fuel cells are different from batteries. Fuel cells require a continuous fuel source and oxygen or air to sustain the chemical reaction. Whereas in batteries, an electromotive force is being produced only when the chemical reacts with each other. So fuel cells can continuously generate electricity as long as these inputs are being supplied. As you can see in the figure there, a fuel cell is made of two electrodes, anode and cathode, separated by an electrolyte plates. The chemical formula of the reaction can be seen in the equation below here. It can be seen that the fuel is going to be hydrogen and oxygen ions, and the output is going to be our energy, which is going to be our electricity in our case, and only some molecules of water. That's why fuel cells are very clean energy resources. Moving with the fuel cell types, fuel cells are classified based on the electrolysis type. There are four different types of fuel cells, which are phosphoric-acid fuel cell, alkaline electrolyte fuel cell, polymer electrolyte membrane fuel cell, Anion Exchange Membrane fuel cell. Each fuel cell type has a different characteristics to fit a certain application. So, moving to the fuel cell stack, a typical fuel cell output voltage is about 0.7 volt when drawing a useful current. A high voltage can be achieved through connecting several cells in series, and which is known as stacks. Fuel cells are arranged in either a simple stack connection or in a more efficient but complex way called bipolar stack connection. The easiest way of doing this is to connect the edge of the anode to the cathode of the next cell as shown in the left figure, in which called a simple series connection. A better solution for the construction of a stack is to make the connection with bipolar plates made from materials with good conductivity, such as graphite or stainless steel. These plates make connections all over one cathode to the anode of the next cell, hence bipolar, as it can be shown in this figure. This is the actual fuel cell in real life application. Next is the techno-economic sustainability study of the system. A techno-economic analysis was performed in this research to find if the hydrogen fuel cell energy storage systems are economically effective, hence sustainable. In order to do that, the fuel cell energy storage system was coupled with a 20 megawatt capacity PV panel arrays to supply a continuous 5 megawatt load, as you can see in the left figure side. I had to compare the fuel cell system with the different energy storage technologies, which happen to be a lithium-ion batteries. So the levelized cost of electricity for both configuration was obtained to find which system is more economically effective and more suitable for the utility grid applications. Also, I compared both technologies, both energy storage technologies, the fuel cells and the batteries, to a PV panel array system with no storage systems to see the effect of including energy storage systems on the levelized cost of electricity. So, as a result of the techno-economic analysis, the table shown in this slide here represents the techno-economic analysis results for comparing the three systems or three different configurations. As you can see, the hydrogen fuel cells system net present cost was around $153 million, which is the highest among all three different options, which is also almost 3 times higher than the battery systems. As you can also see, the net present value of the fuel cell system is a negative, which means this system is not making any profit. Actually, it's losing money, so it's not economically effective. This is actually because the levelized cost of electricity of fuel cells energy source system is about $0.25 per kilowatt hour, which is higher than the electricity cell price, which was considered to be 11.78 cents per kilowatt hour. However, a very interesting result was found is that fuel cells energy storage systems was more economically effective than battery systems when the storage duration period is increasing. For example, having a energy storage system that can store energy for 3 or 4 days, as can be seen in this graph. This graph shows the variation of the energy storage capacity with the levelized cost of electricity. So the hydrogen storage system becomes more economically effective when the storage system capacity is about 340 megawatt hour and higher. Therefore, fuel cells energy storage systems can be placed in applications where long storage period is required. After that period, the hydrogen fuel cells becomes more efficient. And here you can see the blue curve increases, which is for the battery, and the orange curve, which is for the fuel cell, is constant, almost constant. So after that threshold, the fuel cell becomes more economically effective. The last part of the sustainability study is to look at the environmental and legal sustainability of the fuel cell technology. By looking at the environmental sustainability points, we can see that fuel cells have a very low to zero emissions. Also, fuel cells have a high efficiency compared to a conventional internal combustion engines. Also, it is silent when it's operating. It doesn't make noises, which makes it more environmentally friendly. However, manufacturing the fuel cells require a high energy demand. Also, the mining of the raw materials used for the blades require a high energy demand, in which produce air pollution and causes soil contamination. Some other environmental constraints of the manufacturing fuel cells is the platinum that's used for the electrodes, where the platinum is a rare metal that is not easy to be found as pure metal. By looking at the legal sustainability points, the system is actually legally sustainable and encouraged by both federal and local level governments. This can be represented or shown by a tax incentives that exceeds 30%, in some cases 40%, for investments related to hydrogen energy technologies. A negative point of deploying the technology is that hydrogen infrastructure is not yet available. Finally, looking at the conclusion, fuel cells is a medium-near technology, which is a technology at the end of the development stage and at the start of the commercializing stage. So the impact of this technology is expected to be within 5 to 10 years. Therefore, fuel cell storage technology is not yet proving to be sustainable from all different aspects. Fuel cells achieves 40 to 50% fuel to electricity efficiency, and by using the waste heat can bring the system efficiency up to over 85 to 90%. Also, we looked at the levelized cost of electricity for the system, which is about $0.25 per kilowatt hour, which means the system unfortunately is not economically sustainable yet. A suggestion to improve the sustainability of the system is to develop more advanced technologies, more advanced energy storage technologies that can lower the cost of the fuel cell materials. Finally, more research has to be conducted to deploy this technology, since the emission that is being produced out of the fuel cells is very low or near to zero. Thanks for listening, and please feel free to ask me questions. Thanks again.